Hi guys, I'm Vincent from Group B2 and today I'm going to talk about self-assembly. Self-assembly is one of the most promising methods to fabricate a nanomaterial because not only that it is simple, but it also allows scientists to alter the component's properties to obtain a product which functions as they designed to be.
But what is self-assembly? According to Whitesides, self-assembly is the process where systems particles organize into ordered structures or patterns as a consequence of specific local interactions among the components themselves without external direction. There are four important principles in a self-assembly system. The first one is the environment, followed by the particles themselves, and then the driving force that initiates the process, and finally the binding force that keeps the particles together. In this short video, we will demonstrate a simple magnetic self-assembly system where containers attached with magnets are used as the particle, magnetism as binding forces, the water stirring as driving forces, and bowl of water as the environment. Mind you, we are only demonstrating static self-assembly in which formation of organized structure occurs once the system reaches equilibrium. As we stir the bowl of water slowly, we are providing the system with energy while at the same time bringing the particles to get closer to one another. You may have noticed that we stop stirring occasionally and allow the particles to interact among themselves. The reason for that is when we stop stirring, we also stop providing energy into the system. And as the systems try to reach equilibrium, the magnetic force begins to attract and eventually bind them together into an ordered structure. A self-assembly process which occurs at equilibrium is also known as static self-assembly. So thank you guys for watching this video. If you have any further questions, feel free to ask them directly in class. See ya!